Start that. So we shall get going. I'm going to go through some of the stuff from yesterday. We're going to look at quickly writing equations from a graph. There's another kind of section in radicals about just taking the square roots of functions in general. I'm going to look at that this weekend and see if it's something we really need to do or can kind of go on. State the transformations. Where's my cursor? Up there. So we've got a negative in front of the y, so there's a reflection across the x. There's a vertical stretch of 2. There's a horizontal stretch of 3. There's a vertical translation of 6. And a horizontal translation of 5. Right, the mapping rule, x, y. Gosh, my penmanship is awful. There's a negative in front of that and a 2, so we need a half. X minus 3. There's nothing in front. The only y part is y minus 1. Write the equation for the image of y equals the square root of x given the mapping rule. Y equals, the quarter goes out in front. The square root, there's nothing in front of the x, so we don't have to worry. Technically, we don't really need that bracket. X minus 2. And then minus 8. Again, this is all stuff we spend a bunch of time on with transformations, so it's really not that important. X, y, 0, 0, because that's simple. 1, 1. Well, because we're taking the square root of x, I'm going to go to the next perfect square. 4 and 2, 9 and 3, 0, 1, 4, 5, 6, 7, 8, 9. Not 9 and 2, but 9 and 3. Something along those lines. We're up to 10. So far, so good. I hope.
Okay.
Yeah.
At the end, can you or whenever, can you just go to the first one afterwards? Just because I think I missed it. I just wanted to see how you did it.
I just kind of like this one.
Yeah.
So there's a negative in front of the outside, so that's a reflection across the x because it's associated with the y.
Oh, okay. And so it's just like putting them from like vertical to horizontal.
Yeah. You good?
Yep.
Okay. Use a base table of values to do a mapping rule. So what this is kind of saying, it's not, I didn't really do it as a table of values. 0, 0, 1, 1, 4, 2. This is going to have a mapping rule of x, y goes to, oh, there's a negative inside, so negative x plus 3, y minus 4. So all of those points map to, technically these we can call them x prime and y prime. So negative of 0 is 0. 0 plus 3 is 3. 0 minus 4 is negative 4. So what we're getting, 3 and negative 4, that first point where the 0, 0 is, when we, sorry, go back to kind of doing the inverse of a quadratic, the inverse of the vertex kind of stays the same. So the original point there is akin to a vertex. It's not the same because the vertex is the lowest point and it's just this is more a starting point. So negative of 1 is negative 1. Negative 1 plus 3 is 2. And 1 minus 4 is negative 3. So 2 and negative 3, that kind of makes sense. We've reflected across the y-axis, so instead of going like this, it makes sense that we're going like that. Negative of 4 is negative 4. Negative 4 plus 3 is negative 1. 2 minus 4 is negative 2. Negative 1 and negative 2. So we have that sort of setup. If we were doing this at school, like old-fashioned, if you have those points and drew a line, something like that, not marking how good your line is, it's do you have the points in the right spot? Um, the same as your trig graphs, I'm not marking how pretty your wave is. I'm marking, do you know where those 5 points are? So mapping rule, this is the same idea here. I'm going to do the mapping rule down here just so I can see it. X, Y goes to, oh boy, 2. X minus 4. 3, Y minus 5. 0, 0, 1, 1. Every time I do 0, 0 with something like it looks like eyes to me. It kind of sort of semi freaks me out for a second. I'm weird. There's no reflection, so this one should go something like that. Negative 4, negative 5, so we should know where that bit is. Two zeros is 0, minus 4. 3 minus 5 is negative 5. Negative 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. 2 times 1 is 2. 2 minus 4 is negative 2. 3 times 1 is 3. 3 minus 5 is also negative 2. Our original graph goes over 1, up 1. Up 3, over 2. We're going to look at that here in a minute. Da, 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 da. 2 fours are 8. 8 minus 4 is 4. 6 that is a 1. What is going on? I don't know what's going on. Apparently, I can't get close to those points. It's a mental block. So we have those sorts of things. So that's in going one direction. Here's an equation, draw a graph. Well, just like with trig, can we write an equation? And I put this up this morning. We can do it from, let's make that, oh, that's an endpoint and a second point. So we can do this with a graph. We're looking for all of these. This and that give us that original point. The point that we're starting with is negative 4 and 2. So this gives us our H and our K. Normally we're over here, so this looks like it's a reflection not in the X, but in the Y. So if it's a reflection in the Y, we're going to have a negative inside. So our H right now is negative. Oh, let's change colors. Negative 4. Our K is 2. So our equation so far, A square root of, well, we've got a negative 1 over B x plus 4, because that switches. plus 2. And that's... So we have this bit. So there's kind of a couple ways to look at this. Our normal points are 0, 0, 1, 1. If I, well, that was my 0, 0. If I go over 1, well, that's the same. So is there a horizontal stretch? If it's like that, and up 1. So if I go over 1 and up 3, this looks to me like a vertical stretch of 3. So we could say y equals 3. Well, there's no b, so that's just negative x plus 4 plus 2. So that's one way to look at it. But the problem with radicals is there a mathematical difference between those two things I just wrote? Mathematically, those two are equal. The square root of 4x is the same as 2 root x. You do that in grade 10 and that in pre-calc 11. Well, that looks like a vertical stretch. That looks like a horizontal stretch. And why that kind of is over 1, up 1. Well, I did because this is how I look at it. If you do a graph like this and write that equation, check, you're good. I did over 1, up 3. It's over 1. Well, what if I go up 1? Let's use a different color. Up 1. Well, if I go up 1, how far am I going over here? Normally it's 1. Well, that's an itty tiny bit. You can throw that back in here. So I'm just going to show you the algebraic way to do it a couple of times. I'm going to do it for that. And then here's some graphs, write some equations, and that will kind of be it. Personally, I probably would start with 3. Oh, look at that good one. This is your starting point, like just where the arrow isn't. And that'll be it for the day. I don't know why that go away. So another point. Technically, with any math thing, when you're doing any equation, this is kind of what we have right now. Can I put an x and a y in and solve for something? Well, any x and y. Let's use, if it's a vertical stretch, let's use blue for vertical, like that, if we're treating that. Well, another point is negative 5 and 5. So if we're assuming it's a vertical stretch, b is negative 1. If we're assuming it's a horizontal stretch, we're finding b and we're assuming a is 1. So y equals a, the square root of negative x plus 4 plus 2. That's our equation. This is the same thing if you had me for foundations. We did something like this with parabolas. Well, 5 equals a, the square root of negative 5 plus 4 plus 2. Okay, solve for a. 5 equals, well, let's do one thing first. Minus 2, minus 2, because I don't want that there. Oops, wrong color. 3 equals a, sorry about that, square root of negative. Negative 5 plus 4 is negative 1. 3 equals a, well, negative of negative 1 is 1. 3 equals, well, the square root of 1 is 1, so 3 equals a. Well, hot diggity, that's what we found up there. Y equals 3. the square root negative x plus 4. I keep wanting to say squared plus 2. So that's one way to do it algebraically because it's something we need to be able to think about, and practicing algebra is always good. Uh, so in treating it as a horizontal stretch, okay, let's see. Y equals a is 1, so I'm going to ignore it. The square root of negative, because that's still there, b, x plus 4 plus 2. Y equals, oh, no, not y, 5 equals the square root of negative, well, I don't know what b is, negative 5 plus 4 plus 2. I'll move the 2 over again. 3 equals the square root of negative 1 times b. Well, negative 5 times negative 5 plus 4 is negative 1. 3 equals, well, negative 1 times negative 1 is 1. 3 equals the square root of b. Unwrapping, doing the inverse. B equals 9. Okay. Y equals, and that sort of makes sense. The square root of 9 is 3. Square root of negative 9x plus 4 plus 2. Equivalent algebraically because I can ignore, like this is the square root of negative 1 times 9, and I can take that out without worrying about taking the square root of a negative number. This is a vertical stretch is 3, which is what we could see there. If I go up one and over to that one there, we have horizontal, green, a horizontal stretch is 1 over 9. Does that little itty bit, I don't know, I can conceivably say it's 1 over 9. Both are identical. One is no more right than the other. With this graph that we looked at over here, we would list this is a horizontal stretch of, vertical stretch of 3, a horizontal stretch of 2. Well, we can see the 3 and the 2 easily. It's just when you have something like that, and mathematically you can bring that 3 in and have 9 over 4 and everything is all good. So that's how to do it in general. Determine the equation of a radical function that has an endpoint of negative 5 and 6 and an x-intercept of 4. So this is where it starts. Well, an x-intercept of 4 is 4 and 0. That's way down in there. So this has to tell us, it tells me that this has a reflection in the x. It has a horizontal translation of negative 5, a vertical translation of 6. Y equals negative a, I don't know, 1 over b, x plus 5 plus 6. Now, because of that information, if I have those 2 points, that's the only way to really draw that graph. I'm sure you could do a whole bunch of different reflections and say, oh, it's this, that, or the other thing. But if it starts and goes down like that, it's normally going to be a reflection in the x. So, oh, sorry, bracket. Well, I only have 1 point. I don't know which one is really kind of the easier one to solve. It doesn't really make a whole lot of difference. Let's treat it as a vertical stretch for fun. So my points are 0 equals a square root if it's a vertical stretch. B is 1. So this becomes x plus 5 plus 6 with that negative sign. Move the 6 over. Negative 6. This one's going to get to be kind of fun. So move that over there. Is negative 6 equals negative a square root of x plus 5. Okay, not a big deal. Well, I don't like that bit. I just want to double check. I did this one all out at negative. Oh, dividing that over there. So 6 equals a times the square root of x plus 5. I'm either missing something that... Oh, you dumb doorknob. Why do I have two variables? Well, what's the x, idiot? And I'm calling myself an idiot, not any of you. Oh, moron. Do 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 do. Now I gotta. How do I get rid of my x? Well, your x is 0, you stupid. Or 4. So what? 4 plus 5, the square root of 9, the square root of 9. 6 equals a times 3. Like, what am I doing? Divide by 3, divide by 3. A is 2. Y equals negative 2 square root of x plus 5 plus 6. I don't know why I put that in brackets. Don't make the mistake I did and forget to put your x into the equation. Uh, that's just the way, like one way to do it. You can do these just visually and treat them as a vertical or horizontal stretch by eye. There's absolutely nothing wrong with that if you're given a graph. If you're not given a graph, like something like this, you would have to go through and do it algebraically. So that is kind of it for today. There are 4 graphs to write an equation. Find your h, find your k, figure out which way it's reflected. Some of these are reflected more than once. That one looks to be reflected more than once. Oh no, I guess you can treat them all like they're only reflected. That one doesn't have a reflection. But that's all I have for today. It's 10:27. That sounds like a good amount of time. Oh gosh. Okay, I did it again. When I hover, it said 001. I'm like, ah, I didn't record it, but I did. that, that freaks me out every time. So far, so good. Did that make sense? It was quick. It was dirty.
Pick up like
Oh,
to see if we got it right.
to see like the answers to these. Yeah, I can do those after I sign off and then um, just export that. I'm sorry this morning I realized I didn't put up yesterday's notes, the completed version, because I oh I think we ran a little late and Brittany had a meeting at 11 and I just forgot. So
Okay, that sounds good though. Thank you.
okay. Everything else okay? Everybody happy? Thumbs up. We've got. I think there was an email that went out yesterday or something about locker pickup. If you have stuff in there, you should check that. Um, I don't know what they're doing with. If some of you left textbooks in your locker, I have no clue. I Yeah. So it's an interesting situation, but we'll cross that bridge. They haven't asked me for textbook lists, so I don't know. But if everybody's good, that's all I've got for today. We'll carry on Monday either with the square roots of functions or starting to look at exponential functions. I haven't decided 100% yet, but we'll get there. Have a good weekend. Enjoy the rain. You're welcome.
Mr. McKay, can I ask you a question about chemistry really quick?
Sure.
Okay. If you're naming